Mullis, and this is my Physics 2212 Lab Report 1 on the charge tape. So, the purpose of this lab was to stimulate and record the results of two tapes electrically charged transferring electrons. And the tape was used as a point charge in order to demonstrate Coulomb's law in effect. Coulomb's law can be represented by the electric force equal to 1 over 4 pi epsilon times q1 times qt over r squared times the r hat. In this case, 1 over 4 pi epsilon is Coulomb's constant, which is about equal to 9 times 10 to the ninth newtons times meters squared over Coulomb squared. And as well, Newton's second law was used here, which is the sum of all forces is equal to mass times acceleration. So, to show some of the results, the tape was found to have a positive charge of 1.8 times 10 to the negative seventh coulombs, and the electron efficiency of a piece of tape was found to be 1.1 times 10 to the 12th electrons. So, for this experiment, the initial condition was tape B hanging in the air with only gravity acting on it. The system was tape B, the tape suspended in the air, and the surroundings were tape A, the tape that was lifted up to tape B, and the earth. And so all objects on it, myself, the tables, the books that I used to hold the tape. So what occurred was an electric charge was made by removing two neutral U tapes from their base tapes. Tape B acted as a bridge between two objects, and due to the gravity of Earth acting upon it, it concaved, pulling it downwards. Tape A was then lifted up to tape B underneath it until tape B began to float in the air due to the electric force. And this was done slowly, and the distance between the two tapes was measured. So some assumptions that were made was that air resistance on a moving object was ignored. The tapes were viewed and considered as a point charge, and the tapes had equal charges. So here are some of our data from our experience. So the tape had a length of 0.2 meters, a width of 0.018 meters, and a mass of 0.00036 kilograms, a surface area of 0.0003 meters squared. Gravity had a force of 0.002943 newtons. There were 3 times 10 to the 16th atoms per piece of tape, and the electric force, which is equal to the tape charge, was 1.8 times 10 to the negative 7 coulombs, and it had an electron deficiency of 1.1 times 10 to the 12th electrons. This was found by dividing the net charge of the tape by the charge of an electron. And the atoms per electron lost was 3.3 times 10 to the 5th atoms. The tape began to float at a distance of 0.28 meters between the two pieces. Here's my glow script code that I used in order to calculate our data from the results from my experiment to calculate my numbers, as well as here as it is modeled, the forces acting upon the tape, two pieces of tape. So some discussion, some possible error could have been the electric forces of surrounding objects could have influenced this experiment, such as the items supporting tape B, my hands, or the table, as well as my hand was on the tape, it could have messed up the tape a little bit. And that kind of segues into our two questions. Why is it important to handle the charge tape as little as possible? That's because the more we handle it, the more that it can impact and skew our data, as charges could be added or taken away. And when the charge tape comes in contact with my hands or other objects, it can change the amount of charges on the tape. And if the electron had a positive charge and the protons had a negative charge, what would happen? What if that was the case? And what would change about the observations we made in other charged products? So the experiment itself would change, but that would not change, and the two items would repel each other as they'd have the same charges, but instead this time they would have negative charges, the two pieces of tape. Thank you for watching and have a great day.